Hi, my name is Tandros Silbe. I'm an associate professor in the computer science department of the TU Eindhoven, and I'm going to demonstrate to you today our technology that we developed in WorkPackage 21 of the SCOT project. The technology is on self-supervised representation learning that can be used later on for doing, for instance, classification on an arbitrary set of tasks. What the technology does is it pre-trains on multi-stream sensor data, such as the sensors that exist on such a device, and it learns a representation of these signals, and the representation also contains the relationships between the different sensors. So why is it useful? Because by learning such representations, basically by narrowing the signals down to a compact representation, we are able to more efficiently train an end task on top of such a representation. One application of this could be, for instance, you could train to classify an arbitrary number of classes in a given task. So I'm going to demonstrate that now with the app that we developed for this purpose. The app was developed by Akib Said, a PhD student of mine. Unfortunately, he's away on an internship, so I'm going to do the demonstration for you. Let me turn on the app. So the app layout looks like this. For this demonstration, we're going to keep it simple, and we're going to assume that, let's say, we want to train a classifier on only two classes, class A and class B. And so the representation learning is offline, and the activity classifier is learned on the fly, on device, online. So we have a data collection phase, we have a training phase, and we have an inference phase. Let's start with the data collection phase. So what we're going to do is, you can select a class for data collection. So let's select class A. What we're going to do is, I'm going to start data collection, and then afterwards we need to do some activity normally. But since I don't want to run around with a phone for the purpose of this demo, I'm going to just create classes of my own that might not be relevant in real world. Let's start a data collection with class A. So I just started it now. So let's assume I have an activity class A, and I would like to train on samples of that activity. Let's create some samples by clicking start, and I'm going to collect samples by activating the sensors on this device in some way, and this is how I choose to do that for the purpose of this demo. And I have already collected 7 samples, 8. I could go on for a while. Let's collect some 10-15 samples for this activity, quote unquote. And okay, we can stop here. So let's start collecting class B. Let's define a class like this, right? So you can think of separate classes of physical activities like cycling and walking and running and so on. Every one of them will trigger the sensors differently. Talking would also trigger these sensors differently. And okay, do I have enough samples? Okay, let's stop it. I have now collected 16 samples of class A and 17 samples of class B. So what I can do now is I can click training and start, and my training on device has started. The training is obviously on top of the representation learning, as I mentioned earlier, and we can wait for the training to converge to lower loss values, but we have collected only a limited number of samples, so I'm not going to try and wait too long. So let's stop the training. And now can we test what we have learned, what has been learned on the device in terms of classification. Now we are in the inference phase. So when I click start, you see here output probabilities of activities. So I'm not doing any of the activities right now, but if I start doing the first activity, you'll see that class A probability goes to 1, almost 1. And if I start doing the second activity, you see that class B now goes to a probability of 1. So this was a demonstration of on-device activity recognition. Obviously, the same technology can be used for a variety of tasks as long as the idea of self-supervised learning and the resulting representation learning can be applied on the input data. For multi-stream sensor data, time data that is time dependent, this is a very good solution that we found. Thank you for your attention, and if you have any questions, you can contact either me or my PhD student Akib Said of TU Eindhoven.